Today I will explain you the third experiment, and for this just come your announcement about the third experiment and click on the lab report 3. You will reach this page, and to get the report template just click over here. And for the instructions of this video, you can click over here to return. Once you click over here, you get this template for the report. It's charging and discharging a capacitor, and it's about charging and discharging a capacitor in an RC circuit. And what you have the first is the procedure, and you are supposed to know the theory about RC circuits, how to describe a capacitor which is charging with a simple circuit of a resistor R in and discharging. So the basic circuit that you are going to construct is this one. And you have to just a battery, a resistor, and a capacitor of the three circuit elements, and you have switch over here. First, you will bring the switch to terminal A so that the capacitor will start initially charging by the help of the battery, and the charging is controlled by the resistor R and also the capacitance. And once you reach out the full charge on the capacitor, you will just switch the switch from A to B to discharge. For this, you will use a simulation program. And you can reach the simulation program from this link, which is put on the report. When you press in this link, you will get this page. And from here, you are going to download this simulation. It's the Java program. You download it. And once you download it, you will have in your computer most probably download file. So once you download it, you just open it by clicking on it. But if you have trouble to opening, right click on it, select Open With, and then select Java as default program. Once you open it, you get this simulation window. It has blue background, and on the right of the simulation, you have some tools. On the tools, there are circuit elements of wiring, resistors, batteries, light bulbs, switches, capacitor, etc. You can always press on them and drag them over here to build your circuit. It's easy, just select these circuit elements, drag and tie them up, and then build your circuit. Let me show you how you build a charging circuit. We can first put this wire, and then you can put this capacitor, one more wire over here, and one more wire over here. Wires are dragging like piece by piece, and you can always change the length of the wires by dragging from one corner back and forth. And let me bring this resistor over here. One wire over here. It's easy, you see. One wire over here, and then you can put a battery and another wire over here, another wire over here, and we can put the switch over here, and that's it. Initial state for the switch is open. You can always close to run the circuit, but let's start with open circuit because you are not charging a capacitor now. And once you construct the circuit like this, it's going to be a charging circuit. In fact, it's going to be this circuit. Let me show to you. It's going to be this circuit: battery, switch, resistor, and capacitor. You can check it. If you ask what about the discharging process, for the discharging process, the discharging circuit only contains a capacitor and a resistor. There is no battery for the discharging process. So for the discharging process, what we will do is we are going to just take this battery out of the circuit. So to do this, I will show it to you when it comes there. I mean, I haven't started the circuit yet. I've started the charging process. Before charging our capacitor, let's talk about the values of these circuit elements. What's going to be the capacitance in units of farads, and the voltage of the battery, and the value of the resistor? So when you come over here, you see you should adjust the battery to 10 volts and the resistor to 25 ohms and the capacitor to 0.2 farads. Well, one important parameter for RC circuit is that this RC value, the multiplication of the resistor value with the capacitance value. For this choice of values, if you multiply the resistor with the capacitance, you will get 5 seconds. For changing the capacitance over here, just come over here on the capacitance and just right click on your mouse. There appears this selection and just change the capacitance. Change the capacitance to 0.2 farads. And next thing is just come over the resistance, change the resistance to 25 ohms. And then come over here, change the voltage to 10 volts. All right, anytime you can bring and check it, and anytime you can change the values. So now it's ready. Let's run it by closing the switch. I just closed the switch and check what happened. As soon as I closed the switch, the plates of the capacitor started charging. This red plate is a positively charged and the blue plate is negatively charged because the red plate is connected to plus side of the battery, etc. So this charging process continue once you close the switch. The current was flowing quickly and now you don't see how the current is flowing because the capacitor is probably almost got charged. Because if you multiply to 25 by 0.2, you get 5 seconds. 5 seconds is the RC time constant for the capacitor in our circuit. It is, the time at which the current in the circuit drops to 0.37 of its initial value. And of course, we don't know whether the capacitor is fully charged or not. To be able to measure it, we just select the voltmeter on the toolbox. As soon as I select, there appear this voltmeter and the probes. If you connect these probes to the terminals of the capacitor, you can check its voltage. Well, it shows 10 volts. Whenever the terminals of the capacitor plates reach out the 10 volts, which is the voltages of the battery, if you check the voltages of the battery, you will see that it's 10 volts. But it's not exactly 10 volts for the capacitor. It's almost 10 volts. Because, in theory, you have to wait for infinitely amount of time to charge the capacitor fully. But for the time being and for the precision of this voltmeter is fully charged now, in fact, it's not probably exactly 10 volts. Maybe it's 9.99999 volts. But, it takes a very long time to reach out 10 volts. But the precision of our voltmeter is not that precise. It reads out 10 volts. So whenever you see 10 volts, you can open the switch. You can open the switch. You can declare your capacitors fully charged. All right, so this is how it goes. And in order to discharge the capacitor, we have to construct the discharging circuit. But the discharging does not contain the battery. So for discharging circuit, we have to remove the battery. And how do you remove the battery? Just come over the terminals and press on one of the terminals and right click on mouse. It says split junction. So whenever I choose the split junction, disconnect the battery from this side, and you do the same, disconnect the battery from that side and remove it. Okay, and connect the rest. Connect the cables like this, and now you have a fully charged capacitor and a resistor and a switch which is open initially. There is no any current flowing initially because the switch is open, so the circuit is open. But as soon as you close the switch, you will see that the voltage across the terminals of the battery start decreasing. Let's do it. I'm closing the switch now. That is, you see the flow of current in the opposite direction that the battery provides. In that case, you see that how the charges are going away from the plates as discharging process continue. And also you can check that the voltage across the terminals are decreasing, and eventually it will eventually decrease to zero value when you wait for again long enough time. And well, in theory, it's again, you have to wait for a long time, infinitely long, to be able to remove all the charges completely. But to the precision of our voltmeter, this doesn't take infinitely amount of time, just it's zero now, it's almost zero now, but we don't know the timing yet. So in order to also measure time, what we do is we just add the stopwatch to the background. This is our stopwatch, and we will also use this in order to measure the voltage across the terminals of the capacitor at any time, and we will record these values as data. And I will show you how to do this. So let's go back to the charging process again. Open the switch again. I will put the battery again into the circuit so that I can make the charging circuits. Okay. So now in the picture, we have a stopwatch, and you can always start your stopwatch and stop it. Stop it, and reset to zero in any time. And also there is this button over here to control the running all the simulation. You can always pause the simulation, or you can always control whether you can pause it or unpause it. You can always do this over here. When you pause the simulation, if the simulation is running, the stopwatch at that time, the stopwatch will also pause. Everything will pause on here. So whenever you want to read a certain time the voltage, you can always use this button to pause the circuit and then pressing the play button again, you can run the circuit. Okay? You will do this and I will show it to you how to do this. Before I start charging process, I will pause the simulation, all simulation, and I will bring the switch to the closed position. But the circuit will not run because the simulation is paused, and I will run simulation together with the stopwatch. Okay, so because we are going to measure some series of voltages and timing for filling out the table, for the table that we talk about table over here, the table shows these four columns. The first column is just in a showing denoting the data number, and the second column is timing. You will measure time values over here. You measure at specific time. For example, you will measure the voltage value, and you have also this column, which is the natural logarithm of this expression, 1 minus V over V max. V max is going to be 10 volts because we set our battery to 10 volts, and V is this measured voltage across the terminals of the capacitor at a certain time. Okay, and V is always changed as you measure it some other times. You start measuring V at a certain time initially, and then you will wait for let's say 5 seconds and then measure again. Wait for 5 more seconds and measure again, etc. For each of these, you will calculate this term and put under this column. Okay? So this is how you fill out this table for the charging. But let's do this. Let's take me a couple of data to show exactly how you fill out this. I'm ready now to start my readout for the capacitor charging, and what I'm going to read over here just the voltage of the terminals of the capacitor and also timing value over here. Okay, first I will pause the simulation and I will start the stopwatch. In fact, the stopwatch is running now, but since the simulation is paused, it's not running. And whenever you see this button to be a start, that means in fact the stopwatch is running, but it doesn't look running because all the simulation is paused. And at this position, since the simulation is paused, you can close the switch, but nothing will happen. Now the circuit is closed. But since the simulation is paused, whenever I press the play button, the circuit will run also At the same time, the stopwatch will start running. Okay? And at sometimes we will stop the circuit. We will pause the circuit to read a certain voltage at a certain time. So let's start this. Let's start this to fill out the first row, and I will start now by pressing this play button of the simulation, and almost 5 seconds later I will just pause the circuit, and then I will make my first readout, and then I will continue taking these data values. Okay, let me start. I just pushed the play button, so it's running now, and I push my first pause. Well, at 4.35 seconds, the capacitor terminals raised from 0 voltage to 5.81 volts. So let's record these values. The time is 4.35, and the voltage is 5.81. 5.81. Okay. And for this value, what you do for this one is just calculate the natural logarithm of this voltage was 5.81 for this row, and V max is going to be 10 volts because the maximum voltage that the capacitor will reach out is the voltage of the battery, and it's 10 volts. So you calculate this and fill this up over here. Let me do this for you. Let me run this online calculator. Logarithm of the 1 minus the voltage at that time was 6.81. Divide this by the maximum voltage is 10. So that's it. This is equal to this value, but we only take 3 significant figures, so this is minus 0.869. Let's copy this, test over here. Okay. So this is how you fill this last column. To calculate this value accordingly, whatever these voltages over here, let's continue running our circuit because it's paused at that time. Let's continue and take another time value. One option for running this simulation is you can run the simulation frame by frame, step by step. If you press it, the timing will increase step by step as you see over here, and bring this like 5.43 seconds. 5.33. And what was the voltage value? The voltage value is 6.624 volt. 6.624. and calculate the neutral logarithm for 6.624 of the voltage value. Just copy this and paste over here. So again, the value is minus of that much. Again, take only 3 digits after the decimal point. Copy it and paste it over here. So again, let's run the simulation. Run the simulation and wait for, let's say, second timing. Is 6.69 seconds now. Timing is 6.69. For this time, the voltage is 7.386. 7.376. And for 7.376, what is this expression? It is minus 1.337. Let's copy this and paste over here. Let me run one more time, run the simulation for one more time. Pause it. So at 8.28, here, 8.28. For 8.28, the voltage 8.091. 8.091. I will copy this over here, and it is this value now. So copy this over here. So this will go on up to 7 data, but I will stop at the 4 one, and for the only 4 data values, I will do what is asking me to. The report says once you fill out this table, what you will do is you will plot a graph. We will plot a graph and I will show it to you how. You will plot a graph for the step 6. And by the way, let's continue to running the circuit so that the capacitor is fully charged, and leave it there because I need the capacitor fully charged. And what I will do is now I will plot a graph t time on the horizontal axis and this expression on the vertical axis. Okay. For this, you can use Excel. If you don't have Excel in your computer, you can just come to your Google account. On the Google account, you just enter your Google Drive and add a new Google Sheets blank spreadsheet. And once you open this, what you do is form a table over here. This is your timing row, and this is your ln expression. And I will copy all the values over here. Just copy these all values over here under time, and also copy all of these values over here under this ln expression. Once you enter this T column and this ln expression column on this Excel sheet, just highlight all these entries and press on insert chart and look what happens. So what to do next is we are going to analyze this data by plotting a linear fit to this graph. How do you make your plot this linear fit? Let me show it. This is setup and this is customize. In the customize menu, you just find series. In the series, you come over here, trend line, and put it. So when you check this trend line box, this will produce the linear fit, and the linear fit just label the equation. Once you use the equation in the linear fit, you will also get the slope of this linear fit line to be appeared over here. It is minus 0.2 k. When you do this, also you can just check r square and fit measure over here. When you do this, what you in fact get is that you produce this best linear fit to your data. And also the Excel will calculate the slope of this linear fit. In this example, it is minus 0.2. And from this 0.2 information, you will just, figure out the RC value or time constant, and you did it yourself, okay? Also, it shows over here, find the slope of each best fit, and from this slope, you will get the time constant from this slope information. And I just leave it to you how to get the slope information from the time constant information from the slope. And next, after filling out this first table, you have to fill out the second table. But in the second table, how do you fill out the second table? You will fill out the second table for a discharging circuit. And for the discharging circuit, again, you will come over your simulation and reset your stopwatch to 0 and do nothing about this connection of the probes of the voltmeter to the terminals of the capacitor. Let's charge the capacitor fully. It's taking a bit time. In theory, it is infinitely long time. But as you know, since our precision, it doesn't take infinitely long time. Now we have a fully charged capacitor. Let's reset the stopwatch again, and it's charged fully because it produced a 10 volts of a potential difference across its terminals, and you have to just remove the battery because we are going to discharge. For this, just come over the terminals of the battery, and for each turn was the split, and remove this and connect the rest. Now you are just built the discharging circuit because you only have a fully charged capacitor and a resistor. Now you are ready to run the simulation for the discharging circuit. So it just run the simulation by pressing play, and you just started the discharging process. And again pause for some times and get the timing value for the stopwatch, and you get the voltage value. For example, let me just put these first data for the discharging process. The time is 2.64. It is 2.64, and the voltage for this value is just 5.898. And again, Vmax is going to be 10 over here, and calculate this, put over here. So again, do all these 7 data values, playing the simulation and stopping at certain times. Read out the timing and the voltage value, put over here and put this value over here, fill out at 7 data row, and then what you do is you will produce again a graph out of the second table. Just you did for the first table and produce a graph, and again make a fit equation, fit line to your graph, and you will get the slope of the fit equation for the second table, and record it and make some comparison of the slope of the RC value, and you figure out what the RC value, okay? You will be able to get the RC value experimentally from the measurement process. So you will complete, and this way you will complete this experiment by completing the second table. And next thing is just answer these questions, okay? And especially for this step 7, you will find these RC values for both charging and discharging processes from the slope of the plot you produce from the data table. From the slope of the plot you produce from the data tables, all right? And for your plots, just copy these charts and paste them to your report. And I suppose you to paste these plots you produced together with this fitting equation and slope value over here. Okay, I also need this. So that finishes your report.